Yeah. Once this session is done, I'll allow you to uh, see it in YouTube also. I'll post it. Okay. Yeah. So hope you all doing good. Okay. Let's quickly start with our discussion. Okay. Hope you all see. Today's agenda is want to discuss more in detail about solid principles. Hope you all from Java background or from the development background who are having hands-on with the object-oriented programming knowledge like Java or .NET, Python. Am I audible to you guys? Yeah. If you all aware of, if you all aware of object-oriented programming, type yes. The discussion is for you. I see many of you are from my, students. I know you all from Java background. If somebody not from my previous batches. Okay. Yeah. Cool. So far in your journey, you must uh, gone through so much coding, maybe in your core Java lessons or in advanced Java servlets or in your frameworks like Spring, Hibernate. You must involved, right, in the coding area with knowledge or without your knowledge, you might have used some best design principles also in your coding. By knowing it or just by following others, you must have followed it, correct? Or maybe via framework, you must have achieved it, the best practices in the coding. Imagine you must all aware of Spring framework, right? Spring. Imagine if you don't have Spring framework, there you must have learned about what is IOC, what is dependency injection, what is auto wiring. You people learned a lot and applying that on your application. And if you see some people without, having knowledge about it internally, how that pattern is implemented, how it is useful, just by following others, they used to, implement. Others also did in the same way. They kept auto-wide annotation. So I also used. They used stereotype annotations. That's why I used. With their intentions or without intentions, they applied best practices just following the framework features. Though they know about that feature, or if they don't know about the feature, no worries. Framework will apply that feature on that particular application. And frameworks came up with all the best practices by the expert people, right? Every framework designed by an expert. So we just use the expert given framework to make our application strong enough. Apart from the framework, few things that we also should take care, correct? Apart from the framework, during our coding, we need to follow, apart from the frameworks, though you are using Spring or other frameworks, maybe Angular for front end or React, Spring or in microservices you are coding. Framework can provide features until its context, whatever they can able to provide, they can provide. But coming to the practices or methodologies that we should follow, some practices that we should follow to achieve the best coding. Even I can use Spring, you can use Spring, but we need to show the difference in the coding. We need to make application solid, strong, easy, right? When you make your application strong, it is easy to maintain. It is easy to understand, correct? If you imagine the code like 15 years before or 20 years before, people used to do a lot of abstraction. When you look into the code, they made the code in a way that others should not understand. You know, in those days, people used to thought making abstraction is a strong coding. But later, what people realized is, or business realized is, if you make that much abstraction, and if a guy, whoever implemented it, if he left the organization or a company from the project, it is very difficult to maintain that code. Lot of projects are going to shut down because of maintenance issue, isn't it? Because somebody coded it, he's not in that organization now, or he may be not in that field now, he moved on, and others who are looking that code, they are not understanding it to modify. Why? Because they did so much of abstraction. They made it very difficult others to understand. So making it difficult is not a good option, because let's say I have a startup. If I implement an application, if I hire one person, I invested on him, he developed it, everything is going good. Tomorrow he left, and I need someone to understand my application easily, to modify my application easily, and to maintain my application easily. If somebody look into it, easily they should able to understand or modify. Okay. So end of the day, it should be easy enough to maintain. Okay. So we need to follow some designing principles while writing code. As a layman, you need to, you know, uh, keep these things in mind. Okay, I am doing coding today. Tomorrow, if somebody, you know, pitch into my role, how he can understand or how he can modify, or forget about others. You implemented one module a year before, and if you try to look back that module yourself, you can't understand. You will imagine that, or you will think that, is it implemented by me? Maybe if we look back into the code which is implemented 6 months before, even we can't recall it, what we implemented or how we implemented. Okay, why I want to put this is, if you don't follow best practices, obviously you will see problems in future. Okay, we will see how solid principles, there are so many principles that we need to follow. Okay, but in this context, we will see how these solid principles will help us to make our application, you may call it easy or easy maintainable or easy readable, whatever it is, or you may say it is a strong application. Using solid principles, what we can achieve, we will see. Okay, using solid principles, what we can achieve, what beauty we can add in simple words. Okay, there are so many principles, thousands of object-oriented principles we have. We can't apply all here. Based on domain, we have different, design patterns are available. Okay, so we can use them. Coming to solid, okay, so solid means it's not a full word like solids or liquids. Okay, so it's S stands for Single responsibility. O stands for open close. L stands for Lixio. Let me show you that name. Substitution principle. Lisco substitution principle. I stands for interface segregation principle. And D stands for dependency inversion. Few of them we must be following. Okay. Okay. Let's start with yes. Okay. Let's start with yes. Let's start with yes. Single responsibility. Single responsibility. So in single responsibility principle, it states that, okay, what it is saying is a class should have only one reason to change. It's not talking about the initial development. I did code it, okay, you implemented. But if you want to change in future, there should be a only one reason to change that code. I should not have multiple reasons to interpret my code later. Talking about feature, you implement it today and you are done with your job. But tomorrow, if you want to modify, if I ask you, let's say, for example, if it is a employee payroll management, if I ask you to change employee parameters, you should not touch code belongs to payroll. Or if I ask you to change payroll related code, you should not touch code belongs to employee. That means while you are developing itself, if you can make your classes as a single responsible class, in future, you will have only one reason to change that class. Which means you should not create a class with so many responsibilities, which is not belongs to that class. Take any domain. Recently, I did some migration project. There, I implemented a lot of classes. But while designing or while writing the class, that was already there in the PL SQL, we migrated it to Java. So, in PL SQL, we will have procedures, functions, lot of code, database code. They don't follow any rules. Literally, they don't follow any rules. In one procedure itself, they used to put 4 lines, 5,000 lines of code. Databases are strong enough to, manage them. But in our middleware, especially in Java or, object oriented, we should not put that much logic. A class should be a small, easy readable, easy understandable, and should have only one goal to that class. So there I have, some loan information processing system. So we created separate classes for loan, separate classes for, aggregating the loan, separate classes to identify the closing loans are closed or not, for aggregations different. This is how we implemented for each and every use case. We identified each and every independent responsible entity and we kept coding belongs to that entity only. So if you see example here, single responsibility, not only for the Java class, okay, whatever principles I am saying, not only for a simple class I am explaining, I'll be explaining you how you can apply in class level, how you can apply in a application level if it is a monolithic, or how you can apply in microservices level also. Okay, if you see example, employee payroll system, have employee payroll system application. For that employee payroll system, I have Just imagine if you have only one class, employee payroll system, only one class. There you will have, imagine just you have only one class employee payroll system, only one class you have with the employee information as well as payroll information. Okay, employee information and payroll information. In future, I have a change related to payroll. What you will do, you will go to that single class and you will unnecessarily disturb the employee payroll information also. What is the problem in that? Okay, sir, I'll put everything in one class. What is the problem? What is the problem to you? I'll edit and modify it carefully. Okay, no problem. But there is a chance that you may interrupt or you may create issues in the employee class also. Though your modification is simply about payroll, it may disturb employee classes. What classes? Maybe you have written some test cases for employee. The test cases may disturbed due to payroll changes. You have added some other dependencies in your class. So during employee test case methods, you haven't included the dependencies or those mocks that might produce unnecessary issues. Right? If everything is together, if I disturb it, obviously the dependencies will cry. Whichever dependencies across the application, not only a simple class, right? We will have, let's say, if this class is a business class, on this business class, many controllers will depend. Many aspects maybe depend on this service class. If you disturb it, your aspects may throw the error, or your controllers may throw the error, or your test cases, whichever you implemented, may throw errors. Is that good for the maintainability? Not at all. So always remember that each and every class should have a single responsibility. And one more thing, apart from the coding and maintenance, even in collaboration also, we 5 people or 10 people working on this project. Okay, consider we are 21 participants here. We all are working on this project. Consider this is a healthcare project or e-commerce application. I created payroll logic and you created employee logic in a single class. And one day a requirement or two requirements came, do employee modifications and do some payroll modifications. Everything there in a single class. You need to edit it and myself, I also need to edit it. The same file. Okay. Imagine from the collaboration point of view or code committings point of view. If we both work on a same class, unnecessarily there will be a fight between us. If I push code first, you will cry. Or if you push your code first, I'll cry. Definitely, I need to take again your backup. I need to test it. You must have gone through that problem many times. The reason is that's how we implemented our application. If we could have implemented as a simple class, a single responsible class, there is no issues we will see in collaboration. Even recent assignment, one of my colleague, I implemented a class and he added more logic in that class for his functionality. Though you feel that, today I implemented it, today I implemented a class, tomorrow you feel that, okay, this code also belongs to that particular class. To achieve the single responsibility, I want to edit that class. You can edit and maybe modify it. But if that is belongs to a different business, create a separate class, though naming conventions looks the same also, don't put it. You may create separate class and keep it. What happened? My colleague, he added his logic also into my code. Then lot of confusions getting started. When I look back into my code, I'm not able to understand it. That is not the class which I implemented before. And the functionality, Lot of crazy functionality I was able to see there. And the class length also became very big, not even readable. And I started fighting. I asked why you did edited my class. It will disturb my test classes. It will disturb my complete flow. Again, I need to re-verify and recheck whether my complete flow is good or not because of his changes. He may not tested that properly. For his use case, he may tested it. In my use cases, it may break because his new code added some new dependencies also in my class. Why should we do that? Will not allow Java or JVM if you load two more classes extra? Or are you saving the memory? No, nothing. Write any number of classes. Same memory it will take. Hardly, maybe in a bytes, you might see the difference. Why we should, create unnecessary problems to the team members? Not really required. If you follow the single responsibility principle during your development, it will not create any issues later in terms of collaboration or code push or in terms of testing, unit testing, even in testing also, right? If you have implemented your new code in a new class with a new API altogether, tester can easily test this new functionality. He need not to do regression on the existing code. If you change the code, which is already he tested, which is working fine, perfect, if you add new code again, tester need to spend again lot of time. Again, he need to test the previous test cases and new test cases. Lot of regression effort need to be added there. So which is very bad, right? Yeah. So during implementation, identify that if your methods are not belongs to that particular class, keep it in a separate class. Make always your class simple and easy. And remember that it should be easy maintainable, it should be easy testable, easy readable, and don't create, not only in terms of coding, you should not put any collaboration issues also here, right? Are you guys able to follow? Yes. Now coming to monolithic architecture. Okay, you are talking about a single class. Do I need to follow in the classes level only? Will that solve our problem? Yes, that is the first step you need to follow. At least, right? We starts from classes only. Okay, first we start from class. When classes multiplies, many classes, right? When we have many classes, that many classes will become a module and many modules will become a application. In monolithic architecture, we used to keep lot of modules into one application itself. Imagine a e-commerce or a healthcare project. Okay, e-commerce, we must be flexible, right? In e-commerce, we have order management, product management, inventory management, delivery management, customer management. Lot of modules may required for one e-commerce. Imagine if Amazon or Flipkart, these are implemented in a monolithic architecture, server will die. It may not handle that much load. Okay, still, we are not into microservices architecture. Imagine you have so many modules. Imagine you have so many modules in your application. So while designing your modules, let's keep each module should have its own responsibilities. Each module should have its own responsibilities, module level. Let's say if it is belongs to product ordering or product deleting, you have, let's keep it into a product module. You are creating a inventory. I got a new stock. from the factories. I'm selling, let's say, shoes. I want to add shoes into my inventory. I'll use my inventory management system to add that data, the new stock details I will add, then I'll showcase it into e-commerce. So all the, functionality related to inventory, I'll keep it into a inventory module. All the functionality related to product, I'll keep it into product module. All the data related to customer transactions, customer payments, our customers history, comments, ratings, all that maybe I may want it into customer module. So identify the boundaries. If some functionality given, okay, user story is given, and already, let's say you are working on an existing e-commerce, you have one new user story. We want to add a new filter. Customer wants to see last 1 year purchases or last 1 year what he has done in the e-commerce. I want that filter or I want that new functionality. If you ask where you go and implement it, if there is no particular modularity, you don't know what way to go and how to implement it. You will open application, you will see thousands of classes, bunch of classes. You don't know what to do. So you will take in place of 1 day or 2 days, you may take 1 month. Still, you will not find where to add this code. If that could have implemented in a modular way, there is a customer module and all. And if in user story, your Scrum Master or your product owner mentioned that this is belongs to customer module, you easily identify, you will go to your application and you will see packages. Okay, these are the customer module packages. Let me edit there. So easily you will identify what need to be changed. Even if it is a brand new application also, even if it is a brand new application also, based on the number of actors or based on the functionality, use cases, you may create modules. My application is having dealing with customers, my application dealing with inventory people, my application dealing with payment gateway, and my application dealing with delivery agents. Let's keep all these as a modules. Create a separate package naming conventions. You create, right? Com dot, Flipkart dot, ecom dot, keep it customer module or inventory module, so that people can go there and easily can able to add the code belongs to that module only. And during implementation also, this is all we are talking about single responsibility, right? While writing that module also, while writing that module or while creating that module also, right? While writing the code, don't keep all the controller. Let's say if you are working for web application, you are getting data from front end and you are reading that data and you are saving it into the database. If that is the use case, don't create all the controller logic, which is reading from the front end. Okay, let me explain this. Okay, so the basic principle is we should make it as a single responsible. Okay, how much narrow down or how much narrow you can create it. I want to open paint. Let me show all windows. Okay, whiteboard. Okay, so here you people able to see, right? Whiteboard. So I have to implement the user functionality here. I have to implement user functionality here. So I have a form. From there I'm getting form fields. And to read that field's data and to store it into the database, I should not write only one single class. Finally, I want to keep that data into database. So I should not use only one single class to do that. So if I write controller logic, read logic, reading data or validating data, right? And business logic behind that, database logic behind that, DB logic, don't write everything together. Instead, right, you follow this principle, separation of concerns. Separation of concerns in the sense, separate each concern, each functionality. I have multiple functionality here, which is read is one functionality, validate is one functionality, business logic is one functionality, database is logic one functionality. Let's break it into multiple classes. That is what we do in MVC, right? Let's keep this read logic into controller. Let's call it as controller. Validation logic, let's name it like a utility class. Business logic, let's keep it into service class. DAO logic, let's keep it into DAO or repository. In MVC, that is what we do, right? In MVC, what we do, we will have front end. From front end, we read data with the help of controllers. Then controller may use validation utility classes if it want to do validations from form or view. Whenever I get the data from view, when we want to read data, we will implement a controller class. Controller class may use validation classes. Once validation is good, we may send this data to business layer. Once business logic is done, business will send it to DAO. There we do all the CRUD operations, database logic, right? So each concern or each logic which is related to database, keep it here, database CRUD operations, save, update or delete. Business logic, any arithmetics, you can keep it in the business layer. Read functionality from HTTP request or post or SOAP. I'm getting a request, keep a controller. I want to do validations, keep a separate utility class. Why you should club all this together? In future, if you want to change business logic, is it really required to disturb other functionality? Or in future, if you want to change database logic, is it really required to disturb other business and controller logic? Not at all. If you can implement it in a separate class, it is easy to maintain. So that is what saying here in single responsibility. Separation of concerns. Module responsibility you need to take care. You need to create them as a modules. Then during writing your class, don't club everything together. Just break it into multiple layers. And coming to decoupling, module should be loosely coupled. They should interact with each module with well-defined interfaces. So it is easy to debug or maintain. So decoupling, as you are creating multiple modules, even one module wants to talk with another module, create a one beautiful interface between them. Instead of directly again customer module classes, instead of injecting into inventory module, you may create one, one more class which is adapter between your customer module and inventory module, and via that class try to access it. Of course, when you implement a monolithic, you will definitely see this problem also, right? We will have lot of modules. Even I didn't follow while I was working 5, 6 years before. We used to keep everything one module code. We used to take it into another module code. From there, we used to keep it here. We didn't maintain this decoupling. What is the problem if I don't maintain? Definitely we'll see the issue. If one module got disturbed, if one module have a problem, that will unnecessarily create a problem in another module also. How we can decouple it? In Spring we have beautiful features we have for decoupling or for loosely coupling. We are talking, right? By doing interface implementation model, we inject objects into interfaces. Do the same. I have a module A and module B. When you want to give access of module B to module A, create a interface, keep which all methods module A wanted to access, keep that methods into interface and do that interface dependency injection. Problem solved. In case if you have problem in the module B, it's okay. It will create issues in the module B only, not in the module A, at least in the compilation. Maybe when business try to execute it, obviously it will see the problem if there is an error. But at least in the code maintenance, you don't see that problem. And avoiding God objects, right? In single responsibility, you should avoid God objects. What is God object? Same thing, separation of concerns I was saying, right? God object means this is what the God object is. Where it is. This is what God object. If you put everything together, you can call it as a God object. God. If you create God object, what is the problem? It is difficult to maintain. It is difficult to maintain. So what it is saying is avoid such God objects. Avoid such God objects. Avoid such God objects. Try to follow MVC. It is a simple principle while creating. Okay. So if you follow MVC, of course, single responsibility. MVC is the best way for the single responsibility, right? MVC is the best way. If I explain through MVC, right? It is the best way. We create a separate views. We create only reading related logic in controller and only business logic in business class or service class. Only database operations in DO class. If you want login and all, we know by using AOP, cross-cutting corners, logs. If you want, we may create separate log classes or mail classes, right? Each we write it in a separate class for easy maintainability. Just a minute, guys. I'll just come back. Give me 2 minutes. Yeah. So basically, in our spring sessions also, from the day one, we started learning about MVC. Okay. How we used to tell, don't write code very ugly by keeping everything together. It is a maintenance problem. Create a separate class. By knowing our via framework or from the MVC, we learned it already. We are aware of it, right? Almost you are following all the solid principles. But if somebody asks you, are you following solid principles? You may say no. But yes, if you are working in a Spring, yes, you are following solid principles. Coming to single responsibility, are we not following? Yes, we are following in our MVC sessions or whatever we learned. We do always implement in such a way, right? Separate controllers only we used to write, separate business, separate DAO, separate concern classes, validations, utilities, configurations. Everything we used to separate, we used to segregate. That is what? Single responsibility. And saying avoid God object. God object is a object which is having all the logic. It will make this class very complex, not readable, not maintainable. Okay, so that is what God object saying avoid God objects. Avoid God objects. Scalability and maintainability. See, obviously, when you implement by following this, you know, MVC principle or by decoupling, not only MVC for that particular code or that particular use case. When you see application in a broader way, when you follow this modularity, it will be easy. Let's say we are 20 people, we have 20 modules. Without following modularity, if we keep everything together, it's not easy maintainable. And if you want to improve this, performance, where it should go, how I can implement, how I can, scale up my functionality for that particular module, I can't achieve it. But if I followed modularity, let's say customer module is the more concern in my e-commerce. He should not see any delays. There I want to improve the performance. Yes, if I have implemented it as a separate module, I can go there. At least I can able to decouple from there, or I can able to, keep that functionality in a separate application, and I can deploy and maintain, some kind of scaling. If I could have clubbed everything together, maybe in future, if I want to scale up, it's not easy to me to show the solution. Okay. So when you follow the single responsibility, easily you can able to scale up, and it is a maintainable also. Clear? This is in monolithic, but now we are into microservices, right? Nobody implementing such a big application as a single project. Instead, they are deploying lot of teams or many teams parallelly. They are working with many latest technologies, a small service building. Right, what is monolithic and microservice, right? So in monolithic architecture, in monolithic architecture, arrows, we have shapes. Can I find here? No. Okay. Yeah, shapes are available. Thank God. Yeah. So in monolithic architecture, we used to have all the modules together, right? We used to have all the modules, like I said, product module, inventory, delivery, right? And any miscellaneous, all everything together, all the modules code. In monolithic, all modules code, we used to keep it together. Okay, but nowadays that is not recommended. Why? Because maintenance, or let's say I have already competitors in the market, I want to keep my application as soon as possible into the market in next 1 month or 2 months. That's how I planned my budget, and I want to implement it. If I try to make it as a monolithic application, let's say the scope is 12 months scope, I have 12 months scope for monolithic I have. Even if I deploy more people also, I can't able to achieve it. More people creates more confusion. Okay, as a team or a team should have, you know, uh, up to the possible maximum number what we can maintain. Later, it will create a lot of collaboration problem also, communication issues, lot of issues it will bring. So though we have large workforce also, we can't achieve it. That is a problem in monolithic. Instead, instead of that, doing it in monolithic, if you go with microservice architecture, what we can do, we can break this functionality, right, as a separate microservice. We can divide each module as a separate microservice, and we can assign that to independent teams. Let's say you have 12 modules, you can assign 12 modules to 12 teams. Each team maybe have 2 members or 3 members, they can work on it and they can deliver it parallelly. Parallelly testing teams also can test that particular module and they will make it ready hardly by 1 month or 1.5 months or 2 months. So whichever I budgeted or whichever budget I invested, that budget revenue will start from next 2 months so that I may be into profits instead of paying all the interest and all. I'll start getting revenue. So that helps business also, right? So why business should go with monolithic if we have that option? Obviously, nobody will implement applications in monolithic. The challenge is we can't deliver it in a quick time and deploying multiple teams is not possible. Lot of collaboration issues. The only thing is if you want to make it as a microservice application, the scope should be ready. Whatever you want to do, that scope of work or your stories, if they are ready, you can assign this to multiple people, right? Multiple people, multiple, they can start working on it at a time so that they will make it available as soon as possible. That is possible in microservices. If I divide them, if I divide them into multiple modules, I mean multiple microservices, not the module. Modules terminology we use in monolithic. Those modules we call it as microservices. Even each module can be divided into small microservices also. Okay, that's a different context, but assume that for each module you can implement a microservice. Okay, now coming to this principle, next one, solid. We understand single responsibility in monolithic way. If I show you in microservices, if I show you in microservices, how do we achieve it? How do we achieve it? Again, right? While we are talking about single responsibility, that is not only applicable for class. That is not only for class. That is applicable for module level or microservice level. Apply it anywhere, which can brings us the best result. If it is giving best result, why shouldn't we follow? We will follow it. So in microservices, how do we achieve? Make it clear responsible. Whatever microservice you implement it should have clear responsibility. It should have its own particular tasks only. And it should be, you able to see the PPT, right? I hope, yeah. So it should be dynamic enough. Just a minute. Yeah. Each microservice should operate independently. It should be autonomous to maintain its data or, you know, its code. It should have its own responsibility. It should be independent and it should be decentralized. Means code should not be centralized. Code in microservices is decentralized. For each functionality, we create it as a separate microservice. And each microservice should have some boundary context. Means if that is belongs to a customer, a microservice, maybe via customer domain we access it. Under customer domain, we should have inventory access. If you see Amazon or Flipkart, any e-commerce, they will have different domains also, different boundaries altogether for their microservices or for their code. They're not going to use same domain. Amazon.com we use or Amazon.in we use for customer, not for the inventory, not for the delivery. If you see for delivery, they have delivery.amazon.com. They have AWS services. They have aws.amazon.com. Different subdomains also they have. Means for each, we have a separate boundaries. Boundaries in terms of domain also. Not only in the module level, not only in the microservice level, we have in the domain level also. And businesses also. For inventory, they might have thousands of business people only to maintain inventory. That business stream must be different. So when we have separate boundaries, when we have separate segregations, it is easy to maintain. If there are any inventory related problem, as a e-commerce owner or a director, I can ask that particular teams what happened in your domain. Inventory related logic, I should not bring it into customer, or customer logic, I should not bring it into delivery, or delivery logic it should not into other vice versa. So each should have its own clear responsibility and it should be autonomous enough to maintain. It should be decentralized. It should have its own boundary context and we should maintain data isolation, customer data, why we need it in inventory, why inventory people need to see, or inventory data, why as a customer I should see. Not required. If I search a product, if that product is available for the customer, then only I should able to see. All the data from inventory we are not seeing, which is approved, which is genuine, that data only e-commerce will showcase to us. Even they don't access it from their databases. From their databases to, again, they will move it to your database. One more copy they will create. From there, we access it. So always data is isolated, not centralized. Remember that, not centralized. Each microservice have its own database. We don't put a database level dependencies also. This is all what a single responsibility we are talking. So if I am taking responsibility to, lead my home, I need to lead it. I should not leave it on my, mother, or I should not leave it on my wife. So whichever responsibilities I am taking care, I should take care of it. And even I don't involve them to see my information. Everything we don't share even to the family also, right? We used to have our personal about our, strategies, or what we have in the family strategies we may have, right? We can maintain personal, accounts data. That's always crucial to lead the family. We need to isolate so many things. Similarly, in microservices also, one microservice data we will not expose to other microservices until unless that is crucial. We give a API to access some limited information only. And easily we can achieve scalability, right? Let's say I implemented microservices, customer microservice, product microservice, all inventory microservice. Maybe for inventory and for delivery, I may not require huge performance. I may don't want multiple pods or multiple services running parallelly for each country. For all the countries, I have same inventory code or same inventory domain. But coming to the customers for India, I want to give one more interface. For US, I want to give different interfaces because huge customers used to hit every day. One single service may not handle them. I may scale it up by deploying into 30 or 50, whatever maximum possibility that I have to achieve this scalability for that particular microservice. As I created it as a separate service by following single responsibility, easily I can maintain it, easily I can scale it up. And communication collaborations are easy, as I said, right? Communications and collaborations easy. Let's say there is a problem in that module, I can reach out to that module people. I can ask, hey, what's happened in that particular module? Or in case one module wants to talk with another module, via interfaces anyway we provide it. We provide a API, via API they can able to see and they can able to communicate it. Though it is a single responsibility, we are not restricting others to don't look it into my code or don't access my code. If something we need to share, yes, we need to share as per the business. That we can share anyway via APIs. So single responsibility not only in the classes level, right? Not only in the classes level, you can achieve it in the modules level, you can achieve it in services level also. That's where our application will become smooth, easy maintainable, right? Are you guys following? Yeah. Any questions so far on single responsibility? So just maintain it across your application. Okay. So don't disturb others, keep your code and make it small, keep it easy, maintainable, readable. Even you can apply the same rule to module level, you can apply same rule to microservice level. It will be easy to maintain. So that is what strongly you should follow in single responsibility principle. Single responsibility. You need to take one responsibility, single responsibility, not too many. If you take too many responsibilities, it will be difficult to maintain. Right? So if I take too many responsibilities, working, training, and blah blah blah, efficiently we may not put our efforts. We may be interested to do all this, but we can't that much efficient to maintain everything. If we will be in a single stream, there we can showcase best from us, right? So single responsibility will make always your classes easy, maintainable, and lot of things in microservices level. If you see scaling, blah blah blah, that all we achieve. Okay. So coming to next principle that we will discuss in next session. Okay. What I thought is I may be wrap up this in a hour or 2 hours, but definitely it is taking good enough time. So let us meet. Okay. One more session I'll schedule. Okay. I'll ping you in the group. Okay. One more session I'll schedule for 2 more hours. Okay, we will go with again very very important principle, open close, that you may be not following. Earlier I said single responsibility you are following, open and close really people may not following. It is very important principle in microservices, especially in microservices. Okay, we will discuss about it. We will discuss about it in the next session. Okay, I'll I'll share the maybe same link. I'll let you know the time. You people are open to speak. I'm just stopping the recording.